Hey guys, welcome to the second day of lesson 522. We're just going to be focusing on finding inverses of exponential and logarithmic functions. It's not really anything new, but this is just going to be kind of the sole focus of today. So just real quick, please remember how to convert between logarithmic form and exponential form, right? We've talked about that quite a bit, and that is going to be the key to finding the inverse functions of these two types of functions. So here we have two exponentials and two logs. So recall your steps when it comes to finding the inverses of these kinds of functions, right? The first thing you want to do is swap x and y. All right, that's nothing new. We were doing that when we first learned the switch and solve method. And once you do that, you want to convert your function to the other form. And what I mean by that is if you are working with a problem that is exponential, then you need to convert it to log. If you're working with a log problem, then you need to convert it to exponential. All right. So let's go ahead and follow those steps for these problems. So here we have f of x equals 9 to the x. Just remember that this f of x, g of x, t of x, zebra of x, it's, whatever the case may be, those are y's. That's an ugly y. We can consider those to be the y's. This is just the proper notation. And so we can go ahead and rewrite this as y equals 9 to the x, just because that's more comfortable. And now let's go ahead and follow our steps. So step 1 is to switch x and y. So I'm going to write x equals 9 to the y because I've put x in y's place and y in x's place. Now step 2 is to convert this to the other form. Right now it's clearly an exponential form because there's an exponent in there, so we need to change it to log form. Let me remind you what that looks like. Right, we have log base b, sum base, of sum a equals sum x. That's log form, and this is the exponential version of it. All right, and remember, you get that by doing your circle of life thing. So here, applying that, we look at this and we're like, okay, in this exponential version, b is the thing being raised to the exponent, and b is my base. So here, 9 is being raised to the exponent, which means that 9 is going to be my base. That's always the case. The thing being raised to the exponent is always going to become the base of your log. Now in my parentheses, I'm going to have my a value, which if you look over here, a is the thing that's alone on the other side of the equal sign. So for us, that's going to be x. I know that this one is on the left, this one is on the right, but it really doesn't matter which side it's on. All right, and that leaves us to have y on the other side. Now remember, the exponent is always going to turn into that thing on the other side of the equal sign for the log form. That's pretty much all the steps, and then I would just write it in my proper notation. That's not a step that you'll have to worry about on my open math because I always have this part there for you, so you just have to write the log part on my open math. But we are done. All right, let's try this next one. We have, let's switch colors. So again, this is our y, so we have y equals 5 to the x. So step 1 is to switch x and y, so x equals 5 to the y. Step 2 is to put this in log form. So remember, the base is going to be whatever is being raised to the exponent. So in our case, it's a 5, so log base 5 of x equals y. Same idea as over here. So now that I've done that, I'll just, for my properness purposes, rewrite it like this. And I'm done. All right, so that's how you're going to find inverses of exponential functions. And it's actually a little bit more complicated to put things in log. It's more complicated to put things into log form than it is to put them into exponential form, I think, in my opinion. So let's try some where we have to do that. Now we have log functions and we have to switch them to exponential. So for this one, again, remember that this is your y, so I'm just going to rewrite it because I know we're all more comfortable when there's a y there. So now let's do our steps. Step 1 is to switch x and y, so x equals log base 3 of y. Step 2 is to switch this to exponential form. So here's the thing. We've been doing our circle of life thing, and we can do it here too. It's just that the letters are a little, or not letters, but the parts are a little backwards. So we're used to having it written like this when we did the circle of life. Okay, I just flip them. It's fine as long as I keep everything on the correct side of the equal sign. So then we're able to then do the circle of life thing, right? So 3 to the x, and then x to y, so equals y. If we just did that here, it would have been fine, but we would have just had to do a backwards circle of life. So we would have gone this way, 3 to the x, and then this way to the y. So I don't care which way you do it, but if you need to do it, rewrite it like this to do it the way we originally learned, like the same direction, that's fine. But it's really the same thing on this side. You just have to remember to go from the base to the other side of the equal sign to the parentheses. So now I'm pretty much done, but again, I'm going to rewrite it with my proper notation. And I'm done. All right, let's do one more. This is our y, so again, let's rewrite this as y equals log base 7 of x. And then we have step 1, which is to swap x and y, so x equals log base 7 of y. And after doing this a couple times, you'll get used to it. Like, you notice a pattern. If I have log base 3 of x, you notice that it turns into 3 to the x, right? So you can probably take a decent guess as to what's going to happen here. So now I'm ready to put it in exponential form, so I'm going to go ahead and do my backwards circle of life. It's not really backwards, just backwards from the first time we learned it. So I start at 7 and I raise it to the x power and equal to y. So my answer is 7 to the x. And I am done. All right, and that is all for today. The open math problems for today consist of these, but also some other old stuff to make sure you are ready for the quiz.